Hi, I'm Ryan Cornelio.
And I am Isaac Kusunan.
We are from Data Mining Team F, and today we'll be walking through our project, which is about understanding patterns of road safety. Our data set consists of the severity of accidents along with other factors that lead to these accidents, and this data is related to accidents in Great Britain. So here's the agenda that we'll be following this presentation. First, we'll take you through an analysis of the features of the data set, then the factors that differentiate between accident severities, how to reduce high frequency accidents, and how to improve within police jurisdictions. So the data set that we have consists of road accidents in Great Britain in the year 2012. To find out the factors that contributed to high and low severity accidents, we ran a random forest classifier on this data and we got the most important variables. Based on that, we got a list of recommendations to reduce high severity accidents, and then we developed conclusions that would help police reduce frequency of high severity accidents. Based on an analysis of the data set, here are the main interesting points that we found. 15% of all the accidents were high severity. On an average, there were 2 vehicles per accident and 13 casualties per 100 accidents. And in one of 5 accidents, there wasn't a police officer who attended the scene. In this table, you see the factors that could probably lead to high severity accidents. However, contrary to our intuition, made a lot of the road accidents actually happen in good weather conditions and on good road conditions. So therefore, we have to delve deeper into this data set to find out the actual causes that lead to high severity accidents. Severe accidents and which are not. So to obtain the important variables, we ran a random forest classifier on the data, and this is the observation that we got. So we found that the speed limit, carriageway hazards, weather conditions, light conditions, and road type were the most important variables in predicting whether an accident is severe or not. To know whether our model was performing good on the data or not, we kept 20% of the data aside to validate our model. And based on that, we found out that we have an area under the curve score of 0.80, which is quite good for our model. The graph over here shows the receiver operating characteristics curve, which gives us the true positive and false positive rates for different parts on the curve. This table summarizes the metrics that we got from our random forest model, and as you can see, our model is accurate 80% of the times. To find out conditions that actually lead to high severity accidents, we took the important variables given by a random forest classifier and passed them to a conditional decision tree to get rules on which we can actually act upon and develop recommendations. Carriageway hazards were the best predictor of severe accidents. In addition to carriageway hazards, we found that in places that with speed limits above 40 kilometers per hour and in darkness conditions, there was a significant uh, effect through which high severe accidents could happen. Also, in conditions where speed limit was less than 30 kilometers per hour and you had one-way or slip roads, there was a high probability of a severe accident happening. Based on our analysis of the data, these are the conclusions and recommendations that we would like to give to the police jurisdictions. First, enforce a system to take care of carriageway hazards as fast as possible. Second, on roads with speed limit greater than 40 kilometers per hour, ensure that the road lighting is good and that the speed limits are being enforced. Thirdly, on roads with speed limits less than 30 kilometers per hour and on which roads are slip roads and one-way roads, ensure that speed checking is being done since motorists might be overspeeding on these roads leading to high severity accidents. These are our recommendations. Thank you.